Hello guys, welcome to CADMAT. This is our class 12 part 6. So in this class we are going to see some of the editing options in the assembly design workbench. So that left over in our previous classes. So we'll complete in this section the remaining topics. So firstly, editing the constraints in the assembly design workbench. How to edit the constraints, we'll see this now. So prior to that, this is assembly design radial engine assembly. So I'm using this assembly for explaining you, for giving you as an example. So by taking this as an example, let's go for constraints. So you can see there are different constraints applied to here, to this engine assembly. So firstly, if you see this surface contact, you select the surface contact constraint, right click hide or show, and double click on this, and the constraint definition has been opened. So click on more. So as you click on this more option, so on this more you can see the supporting elements dialog box. So in this there are type and components that are involved in constraint together. So these are the two components that are linked by using this surface contact constraint. So in this status you can see they are connected. So how to edit this constraint without creating a new constraint, by just selecting that constraint that you want to edit or change its position or something like that. So by just clicking on this connected, you can see this reconnection option has been highlighted by clicking on this. So if you just click on this reconnect, and so by just clicking on this and select selecting we select this face and click OK and press Ctrl U as it is update option. So you can see the update diagnosis. So showing that there are some other constraints that are linked to this. So we need to edit the other constraints that are linked, or else we can delete this. So just close this and let's try this again. By double clicking this one more and just so I selected the master rod now, and which is in the state of connection. So I just want to reconnect this master rod with this face for surface contact. So now this master rod face has been replaced with this top face. So just see what will happen. And now click undo, sorry, update, Control U. So you can see what happened here. So at first, this bottom face of this rod, connecting rod, and this master rod and this bottom face of this master rod are in contact, surface contact firstly. So now after reconnection by creating a new connection by changing the surface of this master rod from bottom to this top face. So you can see this change has been happened. So this is how you can edit the constraints within the constraint without creating a new constraint. So within the master rod, the face has been changed from bottom to the top. So the constraint has been updated. So if I try to change, undo this one by just replacing it on this reconnect and replacing with this space and click OK, and now pressing Ctrl U, you can see the old position is retained. So after undoing, so this is how you can edit actually the constraints. Let us see the another example. So let's go for this coincident constraint. Let's unhide this one and double click and click on more, and so I'm selecting this master rod. I want to reconnect this one to this center axis for applying the coincidence constraint. So clicking OK and pressing Ctrl plus U, so you can see the constraint has been updated from here to here. So this is how, this is one more example. So this is how we can edit this constraints in this assembly design workbench. The same way you can do them for like surface contact. You can replace the surface contact between two different faces by just selecting the face that you want to replace and by clicking on the reconnect option and selecting a new face. So same way is applied for all these constraints. So I hope you understand. So undoing this one, hiding this one. So now I have told you how to edit the constraints. Now I'm going to tell you how to replace a constraint. So replacing one constraint with other constraint by using this replace option or change constraint option, you can change the constraint. For example, I want to use this, see this is surface contact here, selecting hiding this one and hide this one, then and let us see. So here the surface contact is between the link pin, is the pin 5, and the master rod 1. So okay, link 5. So this is the link 5 on the master rod. one. Where is this master rod one? So where is this master rod? Yeah, here is the master rod one. So between the pin 5 and the master rod one, there is a surface contact constraint. So we just select this and select this replace or change constraint option, and it shows you all the possible constraints that we can apply for it. So if I change the surface contact to an perpendicularity, let's see what will happen. Okay, and let's just control U. So this showing this constraint is just inconsistent or over constraint, I think. So just instead of that, we'll select the other option like so instead of surface contact, I'm gonna select this offset. Okay, so in this offset, I'm going to enter the value as 10 mm and click OK. And now let's update it by pressing Ctrl U. So after doing that, you can see that the surface contact constraint has been replaced with the offset constraint here by giving the value of 10, 0, and Control U. So it looks almost same as that of the surface contact constraint. So you can do that again by just select the change constraint and make it to surface contact and apply. Okay, now this has been changed back into the surface contact constraint from offset constraint. So this is how we can actually change the constraints. Previously we have seen how to edit the existing constraint, and now we have seen how to change the constraint with a new constraint, like replacing the surface contact constraint, the offset constraint, or some other constraint angle or something which are possible, which are consistent, which are possible to apply at this particular area or particular part, particular location. If it is possible, then it will definitely modify the constraint. So just hiding this one. And now we are going to see the one more option here, that is how to see before that we'll be we'll be seeing the flash option here. So to check the flash option between any parts or between all the components or inside one selection, between two selections, or selection against all. So let's see one by one. So first of all, let's just click apply. See, if you see here, there are flash here. So here is the flash here. and the value of the flash is like 11.612 mm is the distance that is in clash with other part here. So here the first one is piston pin and the second one is piston pin plug. Yes, the piston pin is in clash with the piston pin plug with a value of 11.61. And in the status you can see it is relevant. So let's see if there is any other clashes. So all the clashes are with the piston pins only. So there is a clash of 11.61 between the piston pin and the piston pin plug. So this is how we will be identifying after assembling if there is any clashes between the uh, parts or the components before creating a final product. This is how we will be examining the assembly component in this assembly design workbench and making and taking proper precautions can reduce the risk of total loss of after creating a complete model after producing. If there is a like flash like this, if there is a misfit, there is a total waste of time and money. So by before itself in this assembly design you can just identify the flashes between any components by just using this checking flash option here. So in this way you can find the different flashes. Here in this there's a separate preview window will be opened for examining the particular components that are in flash by just selecting here. Select this is just a contact constraint, so there is no flash here. This value is 0. So in case of flash you can see the value, how much is a value that will be involved in a clash between two products here. So in this you can see the filter list like all types clash contact clearance. You can just try them. This is like increasing value or decreasing value, no filter on value, and all statuses you can see, relevant, irrelevant, and not inspected. You can just click on the relevant, then you can see the only the clash that are relevant. So in this type, if you see the clearance plus contact plus clash. So as there is a contact here, so that's the reason you can see the two have been highlighted here in the relevant statuses. So, so if you want to see like inside one selection, you can just try these things. You can just see the different modes of selection. That's it. There is no uh, nothing difference or nothing critical in this. So you can select like between two selections. You can select like first one and the second one here. So after selecting the two components, let's apply. Sorry, this in selection one I selected two products. In selection two I need to select this one. Okay, let's apply. There's nothing. can see again, analyze and clash, and between two selections, selecting the first one as this and second one as this, selection 2 as this, and click apply. So if you see, it is showing there is a contact constraint that said there is no clash, value is 0. Just cancel this one and the clash again in the analyze, and here inside one selection, so the one selection I want to select as this and click apply. You can see there is nothing shown here. This shows there is no any contact or clash constraints. So sorry, clashes that are happened to this product, particular selected product. So there is no list is shown here. I'll just cancel this and again analyze clash, and inside one selection if you select this and apply, there is nothing. The same way if I select selection against all, the whole system has been shown here. Again slash selection against all. Now if I select this field, let's see, so this is how we will be using this clash option for identifying any clashes between the components in the assembly design workbench. So this is most helpful in case of large assemblies. So if you're trying to make that product, so before making the product itself, you can just assemble the components and see if there are any mismatches happening, so that we will be rectifying them in the starting stage of modeling itself, uh, and preventing any losses occurring like any after manufacturing the component. So this is how we'll be using this class option. So coming to the next one is the sectioning. So this sectioning of an assembly is used to like identifying the exact section of this assembly. So for analyze, so in this you can see the sectioning option below this class option. So select this sectioning. By default it will be selecting the YZ plane as the sectioning plane. So if you want to see this section, you can just minimize this. There is another tab open already, section 1. You see here, this is how the section part looks like. So you can just right click and it is remove this 2D lock, and you try to rotate. Now you can rotate it, and again right click, keep the 2D lock. So you can see the clearances and fits and all, whether there is a proper clearances between the joints or links or any overlaps. So it can be seen by using this section view itself. So there are different types of sections like section slice and section box. And coming to this volume cut. If you click on this volume cut and click OK and just go for this main assembly design, you can see the volume cut, how this volume cut looks. So the model has been sectioned here by using this volume cut. So if you remove this volume cut and minimizing this, go back to the other tab of section 1, going to the next option, section slice, select this and just go for this main assembly. You can see the two planes here. You can just place your cursor on this edge of this plane here. You can see the bidirectional green color arrows indicating so that you can move this and select this and can even rotate and just click uh, OK, or else if you want a clear vision just click on this volume cut and click OK. So now you can see the sectioning on both sides, how this looks, the sectioning on both sides. And this is the other second option here. So if you go for the section again and click on this, remove this volume cut and going for this section box, select. Now we'll get a box to section. You can just move the box in whatever direction you want. If you click OK, you just clicking on this volume cut, clicking OK. So you can see the box volume cut in all the different directions here. So these are some of the options that based on the requirement we can use whatever browse section you want, and you can see by selecting this volume cut in the assembly design workbench. Coming to the positioning here, there are different types of positioning here. Go for this section. You want to see the positioning, can adjust the position. This is edit position and dimension. And coming to this is geometrical target. Geometrical target, and this is the positioning by 3 selections. Invert normal, and reset position x, y, x, y, no, and z positions. There are some. This is a grid size. So what is the actual size of the component from the grids? the maximum values and minimum values in x, y directions. Width is 100 mm and the height is 100 mm. So these are in mm units. So roughly for understanding the sizes of assembly. So this is all about the sectioning. So coming to the next one is exploding of an assembly. So exploding an assembly. So just to select, this is the explode option here. So this option you can find it in the move toolbar. So in this toolbar you can find this explode option. Select this explode option, and in this depth just keep everything same. Just click apply. So you can see the total assembly has been exploded. The main use of this exploding an assembly is some of the parts are assembled inside the other parts, so therefore these parts are not visible. So and the user is unable to see all components present in the assembly. So to resolve this problem, the assembly is exploded such that all components are moved from their original position to a location where they are clearly visible. This is the depth all levels. If you keep it in the first level and apply it, you can see very few explosion shown here. So by selecting this first level, the sub-assemblies will remain as it is. So the sub-assemblies won't explode. They remain as a single part, a single component, and the remaining individual components will be exploded. So this will happen if you select the first level in the depth. So moving to the all levels. So in this again type 3D, 2D and constraint. Select the 2D and apply. So you'll be seeing, like if you go for the front view, all the components can be visible. So they will be reflected on a single plane so that you can see all the components from front view or very clearly. So there is no chance of hiding. They will be reflected on a single plane. Coming to this constraint type, you apply by using the constraint type. So by applying this the constraint type, you can see the explosion in a more arranged manner because constraints will be taken into consideration. So that makes uh, this to happen. If you just click on this 3D and apply, there is no consideration of any constraints and all. You just explode into the 3D space and you can animate it, like you can just see how they are moving by just dragging this scroll and click OK. It'll be asking you like sure. If I click S, then it will be saved here in the explosion arrangement. So you can just undo this. Click Control U. So if you press Control U, it will be moved back to the assembled position. Their respective positions, they will be moved back. So this is about the exploiting an assembly. So one more thing that I told to you, that by the end of this assembly design workbench, I will show you this option, flexible or rigid subassembly. So with this option, we will close this assembly design workbench. So coming to this flexible and rigid assembly. So in this flexible or rigid subassembly, I will show you a simple example how this flexible or rigid subassembly applies. So just right click, and you need to make sure that snap automatically to select object is selected. If not, right click and just select this one. Or you can even move a parts by using this manipulation option here in the move toolbar. Or you can just right click on this and select the snap automatically. So then if I go for selecting this master rod, just you can click on this master rod, or you can click here in the specification tree. So you can just click here and just try to move this. So you can see this is a subassembly. So in this subassembly there are three components assembled together. So if I try to move this any part in this subassembly, so it leads to the movement of, so this is not possible to move individual parts in the subassembly. So for that, let's undo this again. What you need to do is, let's just drag it and drop here. uh, just select this subassembly and select this flexible or rigid subassembly. You can see this icon has been changed to pink, dark pink color with some kind of symbol that now the subassembly is flexible. Previously it is rigid, now it is flexible. So because it is flexible, let's try to move the components. Just select the, and you want to select this product one and just drag it. And now I'm gonna select this master rod and drag it. Master rod now. So see, this is now this is possible to move the individual components in the sub-assembly separately. Previously, it is not possible to move them individually. The whole sub-assembly is to move earlier. Now it is possible to. So it is flexible. Previously, it is rigid. Now it is flexible in a sub-assembly. So that's the name indicates clearly the flexible or slash rigid sub-assembly. So we can convert a flexible into rigid, or even vice versa is also possible. So if I, now it is a flexible, if I select this and click on this, and it will be showing that if you make this product rigid, its children will be automatically made rigid. Click OK. So now this is how, now it is rigid. So that's it guys, this is how this flexible or rigid sub-assembly works. So by this we have completed successfully this assembly design workbench. The coming class will be moving into the drafting workbench in this category 5. So hope you understand the class. So in case of any doubts, please comment. If you like this video, please give a like, uh, subscribe to my channel for more videos. Have a good day. Bye bye.